Thank you for joining us. My name is Liran. I'm a developer advocate at Snyk, where we build free developer security tooling for all of us. Who wants to be a hacker today? Yay! My job, though, is to make sure that you are a secure coder today. So, getting that happening. I enjoy spending time building open source software, hacking on Node.js projects, doing security research, and generally just advocating for web security. But I think most of that, and most importantly, I really enjoy doing that with the JavaScript community, with great friends, with all of you here. So that being told, I want to share with you a story today. A story about one of those life-changing moments when you have to take a really hard decision. Yeah. Should I do it myself? Should I ask ChatGPT? Pretty much, I guess, all of us are feeling related to this. And so, as the experienced developer that I am, years of experience, I went off to my AI friend. And I asked it if we can do some stuff. And it had this attitude back, and I remembered, I flinched first. I was like, what? But I remembered, I am the human in this story. You are the robot. So I gathered my nerve and just went away, asked it, hey, I need to implement this backlog story to do a post endpoint of an API upload route with Fastify, pretty simple. It replied, success, kind of job done. It's, by the way, mostly functional code. Maybe something's missing, but I can go ahead and do what everyone else do, which is copy-paste it. Almost, though, I did take a second to read this through, and by the way, all of those are actual snippets of the conversation I had with ChatGPT doing this. So I did notice it kind of like asked me to use one of those methods that doesn't actually exist, so it wouldn't exactly work. I asked it to refine it, and it did. And this is a more functional code that actually uses the FS core module to stream the path, the content of the file that we want to upload, save it to a given path, and success. And I went ahead after this and did what every very senior engineer does. So they get this? Yep. Except there's something here. And maybe you observed that before, and if not, we can talk about it for a second here. And that is the fact that there's a Path Traversal vulnerability here, which is a specific type of a security vulnerability that would allow anyone to basically send requests that actually allow them to either overwrite files in the file system in the case of an upload, or get access to any file on a file system if it's serving the files. And this is real chat from ChatGPT. So obviously, a security disaster waiting to happen, so we're not going to do that yet. Instead, and to actually understand what secure coding is, let's kind of like demystify and understand what are path traversals. So the dictionary definition for path traversal vulnerabilities actually relate to the fact that we may not have security controls in place, such as sanitization or validation. And when we get user input that relates to path-related things like file names or path names or URLs, and they go off and flow into file-sensitive APIs like file paths and path join and things like that, they actually may end up creating vulnerabilities for us. This is the dictionary definition for it, also known as directory traversal. In practice, it looks kind of like that, which is very, very simple, right? To the point where why would this be a major problem? So if you just take this example of the code and traverse the directory as is here, .. / and try to access a file that doesn't exist, you may actually be able to do that. And if you do that, you actually are able to then access files that you shouldn't on a web server. Of course, none of us saves their API credentials and database credentials on the disk, right? No. So while this seems very simple and innocent way, like let's fix it, it's simple enough. And why is it such a significant vulnerability. If you think about it for a second, if I can access sensitive files, the significant risk really rises, right? Because I can access those API credentials. I can access maybe private modules that you have on the file system in your Node modules. I can access your package.json, find out which dependencies you haven't updated, and then maybe they have vulnerabilities, or maybe I can do account takeovers for them. Maybe I can access your SSH keys. I can take all of that information, just relates to like information leakage, and then escalate that attack to something like remote code execution, because I can tie all of this together. So let's see some examples of how this manifests in the wild. My one and prime example here is going to be the HTTP Apache web server, which exists for decades at this point. Its core job is to serve files and requests and manage URLs as its core competence. And yet, it is found time and time again to have path traversal vulnerabilities. In fact, to make you understand how hard it is to do secure coding, and the problem with path traversal here, given the fact that there are probably brilliant developers working on this project, this vulnerability happens due to the fact that there's an incomplete fix to a different security vulnerability that makes this happen. Now, if you ever go on the web and may find HTTP Server Apache 2.4.49, you may use this payload to employ and essentially weaponize the attack and actually access files on disk. Now, at this point, you might ask, well, Liran, where do you go on the dark web to find all of these payloads? My answer to that is I just go to Twitter, which is usually a dumpster fire, but also wealth of information for things like that. In InfoSec, this is the exact tweet and related payload to that exact web server that also mentions how they concatenate it with other commands that escalate the path traversal into reality remote code execution for this web server that we just saw. So real stuff. Where does it meet us on the JavaScript and Node.js land kind of places, right? Like the fact that we deal with paths at some points. Do we understand the subtle differences between path join and path resolve and normalize? Do we understand how they are different, how they should be used, and why they work the way that they do? And that is to say, in fact, is secure coding kind of like easy? Is it? So let's see if we can change that. Path traversal in NPM packages. Our stories are going to show us how path traversal vulnerabilities actually happen and manifest in code that happened related to the NPM ecosystem. We're going to start off with a package called st, eloquently described as a module for serving static files. Pretty popular, get downloaded 500,000 times a week, maybe more, maybe less today. And you'd use it in a very simple way. If this is an Express web application, you'd provide it as a middleware. You'd define what is the URL for public files to be accessible. For example, serving all of those CSS and JavaScript and JSON or whatever you index HTML, whatever you want to serve. And then what is the actual root on the disk? Usually a public directory. Hopefully, by the way, not like this example, not on the same server that provides the actual files. So you do it like that, and you've been to the talk, so you are already quite the hackers. You know how to employ a potential path traversal attack that would actually try to read files off the disk. And if you try to do that to the st package, you'd be disappointed. It doesn't really work. But why doesn't it work? Maybe there's a workaround that we can do to fix this. And so for the next few minutes, we're going to be basically imitating a debugger that looks at the real st code and see how the code flows. Why does it not happen? What else can happen? So here's the getPath function from st. In st.js, there is a function there that actually gets this u variable, which is from the URL. And then there's like a whole dance of URL parsing and path name and replacing, basically kind of like cleaning it up and doing some work there. And turning that path into a URL, it can actually work. The moment it does that, it actually offloads the result of that to path normalize. Now, what path normalize does is, I'd like to describe it as it's essentially eval to JavaScript. That's what path normalize does to URL strings. It evaluates them. So if there's like a ... you actually mean something else. You actually mean you're trying to evaluate and use this kind of string. When you do that, there's like another conditional here that checks that the path that you try to access actually exists within the root directory that you're bound to. Because that is different, /package JSON versus /public something else, then you are not allowed, and things didn't work, as we expected, as we saw before. But there's another concept to the web that's called URL encoding. And that allows us to semantically differentiate what URL special reserved characters mean versus anything else that we want to represent. So we can represent the characters ... with %to %e. Let's take that knowledge and give it back to this get path. As we go through this debugging simulation again, we have this /public to %to e goes off to the path name, goes off to normalize. Normalize does what with it? Nothing, because there's nothing to evaluate. It's not an actual ... or something that it needs to resolve as a path on what you would expect on disk. And so it leaves it as %to e. So we move through the conditional that checked because now /public is /public, the way that this starts. But now this other part of the code decodes the URI. Decoding the URI here basically means transitioning from %to e back to ... And then the rest of the code handles concatenating the path directory that's the root with that was given with the URL. And that ends up with a problem. And that is where path traversal vulnerabilities happened and will happen maybe in the future if you do insecure coding. That is what happened for ST, for example. If you have this knowledge, you would know to then request things like package JSON, and this is how those kind of vulnerabilities happen and impact the Node.js server. Now, I think seeing the fix is as important as understanding what was the actual cause to the insecure coding here. And you could see that it is quite semantic. The author here has replaced the decoding function, the decode URI component, with regular expressions, which is one thing we can talk about later, but that happened. But essentially, path normalize got replaced in terms of the positioning of when it is used. So we first decode, and then we normalize. And that is indeed how you get it right. There is a decoding that has to happen first. So it's kind of like normalizing the strings to what they should be. So you decode the URL, and then you apply path normalize. Now, I will not tell you to apply the rest of the other things that you have to do, like path relative and something else, because maybe you want to build a web server that follows symlinks and allows you to access all of the files with ... If you do, that's fine. But if you don't, then you have to use those other path relative and path join and know that you're concatenating the directories and file paths in a secure manner after you've done all of those checks and not before. So that was one example with NPM packages, one that's like super popular, and maybe you use it in production. If so, please use the latest versions. The other case where this meets us is path traversal in VS Code extensions. Now, at first, this sounds very counterintuitive. Like, what does that have to do with me and path traversal vulnerability? I'm not deploying an extension to production. So let's understand first. There is a path traversal vulnerability in an extension, but it may happen due to the fact that the way that the extension works, and then the attack target is not a production system, because you do not run VS Code on production, but you are then the attack vector as a developer. So the story takes in now a different kind of context. This is a VS Code extension called Open in Default Browser. It literally allows you to open a file in the default browser. It's quite easy. You just right-click it and open the file. You'd think it's very simple, but it has also 1 million installs or so. So it's quite popular. Many users use it. If you're like me, I guess when you go off of your computer from different places and different things that you do, VS Code still runs in the background, right? Like no one really closes that thing. I haven't booted my computer for probably a month by this point as well. So this stays there. And I want to show you how this gets potentially compromising any developer that may run that extension if they haven't updated it. What you'll see next in this video is, first off, on one pane, an actual VS Code. As an example, the right pane is the browser. You'll see how this whole thing works. Essentially, there's test.html, right-click, open in default browser. Ta-da! Amazing extension. But I also want to show you how now the attacker here is able to then open and access any files on disk What's essentially happening now is one of those terminals serves contents of an HTML file. So there's like a PHP thing running the HTML. There's another terminal open with ngrok to allow you to serve this over public, so someone clicks on it and actually can get the web file I want you to download. And then this on most left shows you that, oh, go back for a sec. And on the top left shows you here how there's just two files existing. Now, there's index.html, track.php. I know these fonts are small, but trust me, they are there. That's the way that it works. And then you, as a developer, might be tricked into clicking a website. The moment that you click a website that you're given, the moment that you do that, this happens. You open a website, something gets downloaded, and the moment you did that, it's essentially game over, because as you can see on the left, there are now new files, keys.txt, that were downloaded from the developer's machine. Okay? All of that really happens because the code for the VS Code extension doesn't really do anything about path-related security except concatenating the path and serving the files, because it really needs to load and start a local web server to do its functionality. So all of this is part of some security research that Snyk did a while back and showed some of those vulnerable dependencies or extensions and how they happened. If you want to read more to it, it's a bit more complicated since web servers here run on localhost, and there's the whole CORS mechanism on web browsers that allowed us to have some protections against it, but an exploit still is available, and then we are targeted. That's one example. We've seen the NPM, we've seen VS Code. What about Node? What about the Node.js, the actual runtime that serves our JavaScript? That could also have vulnerabilities. There are teams within the Node project that are tasked with creating code and then also managing security vulnerabilities and releasing security updates. Node itself was, at one point in time, vulnerable to a path traversal issue. It happened, of course, in the path core module and specific normalization function that didn't accurately responded to what .. and how that would be evaluated, like the normalized string here. In fact, it would not require anything else in terms of changes in your code, as if this example here of a very, very basic example of how a web server code for Node.js would actually serve static files. There's nothing bad with this code per se. It's the fact that Node as a runtime would potentially be vulnerable, and if it is, it would actually expose you to path traversal vulnerabilities. As simple as that. I could deploy that attack vector, this GET request, and that would provide me access to this. I wanted to show you how simple it is to also weaponize the fact that you are able to run those GET requests freely on web servers. So over here, I have this server.js file, which it's an upload route. It's a small server.js that does uploads. We don't care about too much about this, but we do care about the fact that it has this /public endpoint. And you can see I'm serving that with the built-in express static file middleware. So I'll go ahead and run that in a container quickly. And I want to show you something else. I want to show you what attackers use in the wild when they want to do some reconnaissance or actually weaponize vulnerabilities. One of those is called ..pawn. What this does is it's a Dockerized version of a tool that basically allows you to go ahead and provide some characteristics of which kind of request you're actually trying to send off to a server, and based on what you're trying to do, it will enumerate and run permutations of different path traversals of those %e, %f, all of those kind of word strings. It will go ahead and send thousands of requests, as many as it has in its dictionary, to servers and tries to weaponize and find those vulnerable instances. You can see this is also hard to find a real true positive example, because some web servers or web application security tools, like on the defense side of things, might actually reply with dummy data that you may expect to have, and you'd think it's vulnerable, but it's not. So you could see how the way that I ran this command has, use the model HTTP URL, look for the keyword localhost in the file etc host, which it will try to access, and then break on the first occurrences of that. All I have to do is run that. My IP probably changed here, and this takes maybe a minute, maybe 2, maybe 4 of those. So it sends all of those permutations of different strings to vulnerable services on the web, whatever you want to give it, allowed to give it, and run them. And maybe you find something. So I'm going to stop it now because it does take a bit of time, but I ran that earlier in the room, and you could see it actually did take 4 minutes. It broke, it stopped on the first vulnerability that it found, and the first vulnerable string that it found, which is this one. Which all I have to do, assuming I still have my the same IP here, which is a pretty big assumption. Yeah, so my IP stayed the same. All I have to do is copy one of those strings, specifically it's this one, which I have to append path as is to let curl know that it has to send it as .. and not encode it on the way to %2e. When I do that, I'm actually able to access this etc host file on the running container here. So it's all running in my machine, both the attack endpoint as well as the vulnerable Node.js runtime. But the fact is, it's a vulnerability that we actually found in a way that we automated the discovery. We didn't have to read the code from anywhere else. So this vulnerability goes way back, right? This is Node.850. Hopefully no one runs that version in production at this point. If you do, please update. So I'm telling you this story because I wanted to show you different cases of how Path Traversal vulnerability finds us day to day, like why secure coding is important. It's prevalent in anything from the fact that we have those extensions that we use that may have insecure coding. It has this NPM packages. It could be code in the way that we implement a get endpoint or a post endpoint for file uploads that we do not maybe do correctly. It may even impact the runtime service that we use or the server package like Bun or Node or Dino or something else if that's not coded correctly. And the fact is, this quote here actually conveys the point where path traversals are actually very significant because the more your application is incorrectly configured, as in there are very over-permissive permissions, right? You are using the root user for different actions. And those kind of characteristics that actually have incorrectly configured applications actually expose you and escalate the attack to those remote code execution and other types of information exposure issues. So with that said, kind of like wrapping up with some of those learnings. So remember that vulnerabilities of this kind could be happening in different places. APIs are really easy to confuse if you do not understand the exact aspects and nuanced differences for them. So please follow those very accurately and understand that those could escalate back in. Now, wanted to leave you off with another idea, which is please practice security tooling as you can, whether that would be npm audit if you run those npm installs and find vulnerabilities. But if you can do something at an earlier point, while you are coding, I wanted to show you how just using the Sneak extension, which is like free on the VS Code Marketplace thing, I would actually be able to find the ST vulnerability for that very popular model that we had. You can see it on the right versus on the left that I basically copy-pasted that to a working example without even using the module, just like my code as if I wrote this module. And it would actually flag me that there's insecure vulnerabilities there. So whatever you could do to find security vulnerabilities earlier in the process, that would be amazing. So thank you very much, and hope you practice secure coding.